Okay, so ratios and percents. Ratios and proportions. Okay, so these are our key ideas. So once again, these are the things that if somebody missed class, you got to tell them, okay, this is what you need to know from this class. So, you should know what is a ratio after this lesson is done. What is a proportion? And the connection between ratios and fractions. Okay, so well, let's get into things and do some examples here. So if you've got Primary Math 5A, now I didn't mention to bring this, so if you don't have it, that's okay, but if people have brought it, maybe you could share with the folks next to you or something like that. Primary Math 5A. I'm looking at page 76, 77. Okay? So we got a bunch of problems here concerning ratios. Okay, so make a note that we're on Primary Math 5A, looking at pages 76 and 77. So a ratio so in these examples, Primary Math 5A, page 76. Write each ratio in simplest form. Let's do a few here on the board. Okay, this is a ratio. Okay, you've kind of got a comparison of two numbers. Okay, 4 to 10. So what is that in simplest form? You probably know what it means already. I know we haven't talked about it, but I bet you can infer the simplest form for this ratio.
2 to 5.
2 to 5, okay? So the ratio 4 to 10 simplified to 2 to 5. That's the simplest form of the two ratios. How do we know we can't simplify it any further? Okay, 5 is, there's nothing common between the two. They're both prime, in fact. Okay, but they don't really have to be primes. They just have to have no common factors. Look at part B there, 12 to 18. Simplest form. Say again? 2 to 3, right? So we're looking at that factor of 6. Okay, ratio of 12 to 18 is equivalent to a ratio of 2 to 3. Okay, so a proportion is a statement that two ratios are equal. A proportion is a statement that two ratios are equal. So, I want you to look here, if you've got the textbook, if not, I'll just write it on the board here. I want you to look at problem number 5 on page 77. Okay, the ratio of the length of ribbon A to the length of ribbon B is 7 to 4. Ratio of the length of ribbon A to the length of ribbon B and they tell us ribbon A is 21 meters long, so if ribbon A is 21 meters long, what is the length of ribbon B? Okay, so word problem. Ribbon A there, got ribbon B here. Okay, how many segments should I break ribbon A up into? Okay, 7 segments. And how many segments should I break ribbon B up into? 4. Okay, now. 1, 2, 3, 4, 5, 6. Okay, and should I do this? Is this a good picture? No, not a good picture. Even though I broke ribbon B up into 4 segments. Why isn't this a good picture?
Because they're not equal length.
Okay, right. The picture I have implies ribbon B is the same length as ribbon A. That's not right. Okay, it said the length of ribbon A is to the length of ribbon B as 7 is to 4. Okay, so ribbon B is almost twice as long as ribbon A. In other words, my picture should look like this. Okay, now why would I have my finger up there like that? What was I doing? Right, that's where the 4th segment of ribbon A is. 7 segments to 4 segments, and they've got to be equal segments if we're talking about the lengths ratio, 7 to 4. Okay, so what else do I know?
A is 21.
Okay, length of ribbon A is 21 meters. So this bar is 21 meters long. And my diagram should have a question mark in it somewhere. So where should I put my question mark? Right, underneath ribbon B, so I'm trying to find that. There's my question. So, we over here can do this. 7 units equals 21 meters. So 4 units equals what?
12,
4 units equals 12 meters. How'd you get that?
because 7 times 3 is 21, so 4 times 3 is 12.
Okay, right. So basically, you can figure out how long 1 unit is from this, divide everything by 7. So 1 unit must be 3 meters long, and then multiply by 4. So 4 units must be 12 meters long. If we're talking about ratios, this ratio, 7 to 4, is equal to 21 to blank. Okay, so this is a proportion here, a statement that 2 ratios are equal. 7 to 4 is the same as the ratio 21 to what? So we're saying 21 to 12. Okay, now notice how we got these from this. Okay, 21 is 7 times 3, so the number that fills in this box should be 4 times 3. Okay, so you can preserve ratios if you multiply both parts by the same non-zero number. Multiply both parts by the same non-zero number to preserve the ratio. Okay, let's do a couple more word problems here. So you've got elementary math for teachers with you, right? I hope. So go to page 169 in elementary math for teachers. Oh, rats, they actually do the example here. Let's go to page 170 in elementary math for teachers. I want you to look through example 1.9 on page 170.
What did you say?
Example 1.9, which is up at the top, on page 170 in elementary math for teachers. Do me a favor and draw out the bar diagram for that. So write it out in kind of teacher solution form, kind of like we have right here. Page 170, example 1.9 up at the top. So show me your diagrams here. What do you got for your diagrams? Okay, right. So basically, the original ratio should tell you the number of segments you should have in each of the diagrams, and they should be equal segments. So the bars will be unequal lengths. Okay. So, okay, sorry, I'm gonna need to borrow yours. Let somebody borrow mine. Group. Okay, girls to boys is 4 to 5. 12 girls, find out how many boys. You know that's 12. There's your question mark. Okay? So phrased as a ratio, the computation could look like this. The ratio of 4 to 5 is equal to the ratio of 12 to 1. So now what we have to figure out is, how do we get this number to look like this? And what do we do? Right, multiply by 3. So if you multiply this first number by 3 and you want to keep the ratio the same, what do you have to do to the second number?
Multiply 5 by 3.
Right, also multiply that by 3, so we get a 15 there. Okay, so what does that tell us about the answer to the question? Right, there are 15 boys. So one thing to note about these ratios is they are talking about relative amounts. If I just said the ratio of girls to boys is 4 to 5, how many boys are there? That is not enough information to answer the question. Okay, every 4 girls is 5 boys. So the question is, how many 4 girls are there? If there's 12 girls, there's 3 groups of 4. And each of those 3 groups of 4 leads to a group of 5 boys. So 5 plus 5 plus 5. Okay. So go back to 5A. Flip over to 79. Okay, we're going to do one pretty straightforward problem. We're going to do one that's a little bit harder. Okay, I want you to look at number 2 and number 3. So number 2 asks us this: the length of a rectangle is 16 centimeters, and the width is 12 centimeters. Find the ratio of the length to the width. Length is 16, width is 12. Find the ratio of the length to the width. So this one shouldn't be too bad. What do I do with these numbers? What's the, how do we start out? What do I start out with? Okay, ratio is 16 to 12. Okay, now would I keep it like that? I would probably put it in simplest form. Okay, so what is the simplest form of that ratio? 4 to 3. They both have a common factor of 4, so we simplify it that way. So the ratio of the length to the width is 4 to 3. All right. Now, here's another one I want you to try. I want you to try number 3. Okay, so we're in 5A. We're on page 79, looking at number 3. Ali won $50. He saved 35 and spent the rest. It asks us to find the ratio of the money saved to the money spent. Okay, I want you to take, let's say 2 minutes in your seats. And write out an answer to this question. Ratio of the money saved to the money spent. Okay, so help me out here. What about, what if I did this? Do not write this down. Okay, so let me see. Okay, I got 50 to 35. So that is, let me see, I guess that is 10 to 7. All right? Now, what's going wrong here?
Because we made it 35, it would be amount saved, the amount spent.
Right, you've got to be careful to look at what we're making the ratio with. We're supposed to be making the ratio with money saved versus money spent. What is the $50?
The total amount.
Right, that's the amount of money that he won. So this is the amount of money that he won to the amount he saved. That's not the ratio they asked for. Okay? These problems are only like 2-3 sentences long. You got to pay attention to the whole thing. Every sentence is going to give you important information that you're going to need to use. So you can't ignore this stuff. Okay, so first we have to figure out, they tell us how much he spent, right? The money spent is $35. Okay? So how much did he save? What do I do?
50 minus 35. 35.
Okay, right, so he must have saved the rest. He must have spent the rest. 150, saved 35, that means he spent $15. Okay, now what do I do with this?
35.
Right, the ratio is $35 saved to $15 spent. And we could simplify this. How do we do that? Right, divide both by 5, there's a common factor there, so the correct answer is 7 to 3. So this is something that'll come up quite a few times dealing with ratios and proportion. Okay, the ratio of what to what? The ratio of the total money won to the total money spent is not going to be the same thing as the ratio of the total money saved to the total money spent. Okay, so we've got to pay attention to what quantities are involved. This will come up again when we talk about percentages. To say 5%, well, 5% of what? If we don't have that second part, then we really can't do any work. Okay, 2 more that I want you to work on. Flip to page 82. I want you to do number 4 and number 5.
Is that in 5A?
Oh, sorry. 82. Page 82, 5B. I want you to do number 4 and number 5 on page 82. Okay, for those of you that don't have your book with you today, I'm going to write it on the board. So, number 4 says the ratio of, actually I guess it's girls to boys, that's important. Oh, no, that was right. I had it written right the first time. The ratio of boys to girls is 7 to 4. There are 128 children in the club. How many boys are there? I'd like you to draw a diagram for this.
121.
Oh, 121, thank you. There are 121 children in the club. How many boys are there? Draw a bar diagram for this. One single diagram. One single bar. Don't draw 2 bars. I think it'll be easier if you draw one single bar. And let me see here, number 5. William has $120. Steve has 20 less than William. What is the ratio of Steve's money to William's money? Definitely draw a bar diagram for this. I think it will be helpful. Might not need. So help me out with this one here. How many segments should my bar diagram have? Say again? 11 segments altogether, okay? This is the reason I thought it was better to use a single bar diagram here. I guess you could have separated it into two, but okay. So I've got 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this over here is the girls. This over here is the boys. What do I know? Right, there's 121 altogether, so I know the total length. 121. So what do I do to get the number of boys? Okay, 11 times 7. Now, the reason this could be a little misleading is not because there's 11 boxes. It's that because if I take 121, divide it by 11, I get 11 back. Okay, so I got to take the total length and divide by 11 because I know 11 units correspond to 121 kids. So 1 unit equals 11 kids. And then 7 times 11 gives me 77. So there are 77 boys in the club. Okay. How do I do this one here? What can I do? I want to find the ratio of Steve's money to William's. Order is very important. Okay, we've got to put the things in the right places, just like with Ali's money over here. Okay, you can't just take the numbers and start making ratios. You got to put them in the right order. So what goes first in this ratio?
Steve's money.
Steve's money. How much money does Steve have? $100. Okay, so Steve has $20 less than William. So we start with William's and we take away 20 to get how much Steve has. So Steve's money to William's money is 100 to 120. Help me simplify this ratio.
5, 6.
Okay, 5 to 6. Okay, you can certainly start by doing that because you're taking away a factor of 10. You're dividing both sides of the ratio by a factor of 10. So you got 10 to 12, and there you can see both sides have a factor of 5. So you can divide that out as well. But no, they don't. They both have a factor of 2. So you divide out the 2, you get 5 to 6. Okay. Okay, so here's the thing to note. To say the ratio is 5 to 6, is to say there exists some unit of measurement such that Steve has 5 of those units and William has 6 of those units. Okay, now, if we were talking about this ratio, 100 to 120, the unit I'm talking about is the $1 bill. Steve has $100, William has $120. So if I gave them all dollar bills, Steve has 100, William has 120. What's my unit here? What does Steve has 5 of and William has 6 of? $20 bills, that's the unit of measurement here. If we were to phrase things in terms of $20 bills, Steve has 5 of those $20 bills, William has 6 of them. Okay, so that's what a ratio is. How much one part has compared to how much the other part has for some unit of measurement. Now you gotta use the same unit on both sides. Okay, you couldn't do 100 to 6. That's not the correct ratio because you're not using the same unit. Okay, now you gotta be a little careful with ratios. Ratios are not numbers. Fractions are numbers. Now when I say number, I mean things I can do arithmetic with. Now when I say things I can do arithmetic with, I mean if I have 2 of them, I can add them together and get a new one. If you have 2 fractions, I add them together, I can get a new fraction. How do I add fractions again? Right, common denominator. Remember, that's something that both of your denominators have to go into evenly. Okay, so I got 2 fractions, I can add them together and get a new fraction. I cannot do that with ratios. Okay, there is no good way to make sense of adding ratios together. Okay, let's look at an example here. So, a boy writing ratios as fractions. Ratios are not numbers. Let's look at a quick example to show us the dangers of doing that. A bag contains six white marbles and 10 red marbles. We add 4 white and 20 red. What is the ratio of white to red? Okay, so what do you think? What makes sense? Trying to find the ratio of white to red.
The white ones together and-
Okay, so add all the white ones together. So 6 plus 4, so we have 10 white marbles. How many reds? 30 reds. Okay? So, now let me see, my original ratio was I had 6 and 10, right? 6 to 10. Plus, quote unquote, plus 4 to 20. Okay, now we know that this should be the ratio. At the end, we got 10 white marbles, 30 red marbles. Okay, can we simplify that at all? 1 to 3. Okay, they both have a factor of 10. Now, the reason I'm saying and emphasizing that ratios aren't numbers is because if I were to simplify these ratios first and then do the addition that we just did, because it seems like the rule for adding ratios, you take this plus this for the one side, and this plus this, and that's the other side. Okay, I could reduce these first. Let's see what happens. What do I get if I reduce this? Right, 3 to 5. Common factor of 2. How about this? 1 to 5. Okay, common factor of 4. If I apply that rule that we just learned up there, 4 to 10, which is the same as 2 to 5. Okay, but that's not true, that's not the ratio. We know there's 10 red and 30 white. Okay, so you simply can't do arithmetic with ratios like you can do arithmetic with fractions. So if you're working with ratios, keep them written as ratios. Don't write them as fractions. Okay, so I need to get started on some homework here. Read the first section of Chapter 7 in Elementary Math for Teachers. That goes from page 167 to page 172. I want you to work on problems 1 through 5 and 7 on page 172. Problems 1 through 5 and 7. Okay. Got your